All right, number one says a box is sliding along the floor as shown in the diagram below. The coefficient of kinetic friction between the floor and the box is zero point 0.2. It asks what is the normal force acting on the box. So what you do is say the normal force equals mg plus 60 sine 30 because that's the force acting downwards on the box, and you get 118.2 newtons. B asks, what is the force causing the box to accelerate? So what you do is 60 cosine 30, because that's just the horizontal element of the force, and you get 51.96 newtons. Okay, C says, how fast is the box accelerating? So to find the acceleration, you do 51.96, which was the horizontal, minus zero point 0.2, which is the coefficient of friction, times 9.8 times 9 plus 60 sine 30, and you get 9a. So the acceleration is 3.15 meters per second squared. Finally, D says, assuming the box starts at 1 meter per second, how far will it travel in 3 seconds? So I used the equation x equals v naught t plus 1 half at squared, and you get x equals 1 times 3 plus 1 half times 3.15 times 3 squared, and you get x equals 17.2 meters. All right, number 2 says, an experimental elevator has been outfitted with a spring scale to ensure that the elevator will not cause problems when it accelerates. The mass of 78 kilograms is placed on the scale, and it asks, what will the scale read when the elevator is standing still? So to find this, what I did was just find the weight, which is mass times gravity, and you get 764.4 newtons. Now B says, what will the scale read when the elevator is accelerating upward at 2.5 meters per second? So what you do is you do the weight plus ma, and you get F equals 78 times 2.5 plus 78 times 9.8, which equals 959.4 newtons. All right, C asks, what will the scale read when the elevator is accelerating downwards at 3.2 meters per second squared? So what you do is force equals the weight minus the ma, and you get force equals 78 times 9.8 minus 78 times 3.2, which equals 514.8 newtons. All right, number 3 says a 13-kilogram box is pulled down a 15-degree ramp by a rope that runs parallel to the ramp. The coefficient of kinetic friction is 0.450, and the coefficient of static friction is 6.650. So A says, what is the tension is required to get the box to move? So what I did, I said F go minus F slow equals ma, and then since A equals 0, you said F go and F slow equal to one another. Then you do, the F go is tension plus weight times the sine of 15 equals 0.65, which is the static friction, times F normal. So after you're doing all that, you get tension equals 47.0 newtons. B asked, if the tension in the rope is 100 newtons, how fast will the box be accelerating? So what I did, I said F go minus F slow equals ma, but this time you can't set F go and F slow equals one another because A is not 0. So what I did was 100 plus 13 times 9.8 sine of 15 minus 0.45 times 13 times 9.8 cosine 15 equals 13a, and you get the acceleration equals 5.97 meters per second squared. Number 5 says, a system of masses is set up as shown in the diagram below. Find the acceleration of the blocks and the tension in the string between them. And it also says you can assume the surface is frictionless and the hanging block is moving down. So to solve this, you have to make an F net equation for each of the boxes. So after you do that, you just set the two equations equal, and you solve for the acceleration, which I got to be a equals 6.4 meters per second squared. And then after that, you just plug in the acceleration into either of the F net equations, and you get the tension to be 136 newtons.